Hey, this is Steven from Legit Tech Tutorials and the Green Engineers, and we're going to revisit a very old project, but I have some stuff that I have to work on with that project. So basically, I wanted to revisit that as it's basically going into the market here very soon. I actually ordered some of them to be machined. So I'm going to look at the last time here on my channel, last time I talked about it. Let's take a look here. Wow, last time I talked about it was that the last time? Yeah, it looks like that was the last time I talked about it. It was 2 years ago. Well, 2017 March. So 2 years ago, pretty much, was the last time I talked about it. And I think that was originally when the project was devised. So basically, if you can't remember, I'm going to be talking about the shredder here. So I guess this would be shredder, and I just closed it. Let's see here. I think it was number 12. So this is shredder part 12. Wait, sorry, 13. So I did do, the last video I showed was a prototype build of it. So a few things have changed since then. Let me go ahead and get you guys filled in on the few things that changed, and then we're going to go forward. So basically, one of the things that have changed is I changed the gear. So the gear now uses a actual calculator inside of the system. Here it's an add-on. Let me see. Anyways, anyways, yeah, so it's a calculator in here. I'm gonna have to find it again. It's our tools, maybe add-ins, scripts and add-ins. Oh no, the make button is in tools now. Oh, that sucks. Anyways, spur gear. So you go in here and you set the pitch diameter, the root fillet stuff, and all this kind of stuff. And basically I messed with this till I got the pitch diameter that I needed, which are basically that these two gears are touching each other. And so now this is the basically what I have now. Oops. And I added one extra thing. So it used to be that this was just going to bear on the piece of... Oh, so I didn't... I guess I haven't put the gear back in there yet. Which I can. There's quite a bit that's changed in this model itself. And we do need to update this model to get to where we need to be. And usually when I update this, they get all latest, this whole thing crashes because pretty much this entire thing is made from outdated parts. So that's another thing is in Fusion, once you change something, make sure you go back to the layout and update the parts. So these are old now. I mean, we could pretty much get rid of them. And I can show you guys what has changed pretty much. So now this is not how it used to be. This is different now. So basically what happens is this shaft's a little longer now. So now, let me see if, do I have a picture of it? Let me see what we got. media. And obviously all this stuff was done off stream, pretty much. I mean, not off stream, but off recording. Let me see. View, extra large icons. Oh, wrong one. Let's see, do we have it in here? Okay, so here we go. So I did have one prototype made, and so what you see is the guy messed up. I wasn't paying enough attention, and he actually nested the same one 24 times instead of the progressing angle. So do I have that in here? Oh yeah, so this one doesn't have that. So basically what happens is, another thing that I added was that each of these dials actually goes at a progressing angle. So each dial is indented 15 degrees forward. So it goes 15 degrees. So it's like this is these two teeth here are gonna engage first, and then these two teeth, and then these two teeth, you know, etc., etc., etc. So that way you have a very small load, one at a time, and then that load is happening every 15 degrees. That load happens. So instead of, as this is going in, you have a massive amounts of load because all these teeth are trying to cut. It's only cutting small. It's only trying to shear one small section. So that's number one, and you'll see this piece here, which is called, I call it the bearing bra, and I'll show you guys basically what that does. So pretty much what that does is that there is a bearing here. I don't know if you guys could see it. Do I have a picture of the backside? I do not have a picture of the backside of the bearing housing of the shredder, but because on the backside there is no gear, and you'll actually be able to see that there is this big bearing in there, and that bearing is pretty big. Do I have it in here? I think it's a 60 something. Let me see. I actually have the prototype sitting right here on my desk. Whoa. So let's pick this thing up and turn it around and take a look. And this guy obviously is going to be replaced here pretty soon with my actual prototype, which I ordered from a WaterJet production prototype, which I ordered from a laser cutter here today. And so I'm going to have 9 of these guys made here pretty soon. So this is a 6006Z. 6006Z. And so basically what that is pressed into this 1/4 inch steel. And this bearing is actually 1/2 inch thick. It's pretty much exactly 1/2 inch thick. So what that means is that because it's only 1/4 inch thick, we need some additional support. So what I did is I also put in these bearing supports here. And so you put these bearing supports, and then you could either press the bearing supports onto the bearings you already pressed in, or press them in all at once. I would prefer pressing into this 1/4 inch piece, and then pressing the bearing supports in on top of that. And what that does is, actually you're supposed to weld it. I haven't welded it yet. So you go in here and weld this guy, and then you're going to put some water on the bearings because you don't want to superheat the bearings on the inside. And then obviously you have your welding here, so you want to also protect the bearings there as well. So go very slow, weld here, etc. So this is a new addition that you do not see here. So with that being said, these holes are no longer there. And this is just welded on here, and this will just be spot welded on, probably very slowly. And also you could see these nice gears. And these were originally designed as zero backlash gears, but in actuality I am making it so that the tolerance is high. The tolerance is very loose because right now these teeth are extremely tight. And so they are going to have to be moved quite a bit in order to have in order for them to wear together so that they are good. I mean, that's basically the whole machine needs to be run on a motor first to have everything kind of lap itself into tolerance. So that's one of the things that's changed. So this is no longer like this anymore. You have this hole is for that big 606Z, 6006Z ball bearing. And there's 2 of them. And then basically this piece right here goes inside of the bearing. Oh, speaking of which, I probably should have two. Because again, the bearing is 1/2 inch thick. And I actually need two of those bearing supports. Two on each side, so I need to add that tomorrow and tell them, hey, actually I need four of those bearing supports. Because here, we only have one, and the bearing is 1/2 inch thick, so there should be two bearing supports in there. So that's another update I need to make on the drawing. Speaking of which, I need to do that tonight then, to make sure that I get it to the the laser guy, before he starts working. So that's basically what has changed. And so that's on both sides. That's on the front and the back, have both that. And then obviously these teeth are in there. Let me push this thing back. So these teeth go in here. And so basically these teeth go here. So I'll be updating this model probably in these videos as well. Because we do have this guy in my last video where you guys saw that I made the prototype out of plastic. And I made some changes where these are actually slightly inside, by basically dropping this a little bit, this tolerance here, I believe. I believe I made that change. I'll have to check, because these are, did I actually make that change? That's a good question. These are 2.5, and so this is the new front and back, which is this. And then here you see the front and back support. I call it the bra. So let's see here. Okay, so it looks like I didn't. So what would be nice is if that's actually slightly smaller. But what I did tell, and the issue is I did tell them this should be smaller. So maybe I should look back through this tolerance sheet and set everything else up. Luckily he gave me some extra time, and hopefully it doesn't change the cost too much, because altogether it's going to add another 32 parts, but each part is going to add another 4 parts for those bearing braces. And then the tolerance here, it needs to be a little closer. So basically what that issue was that I had was that when these two dials turned, when this blade tried to enter, it kind of struggled because of the tolerance issue, because of the tolerance stack up, because the 1/4 inch sheet is not actually 1/4 inch all the way down. Obviously it vibrates a little bit. So what happens is that when you try to do that, the blade had a problem entering in to the other blade, because it wasn't quite properly aligned here. So the idea is that this is actually supposed to be inside this other piece by a little bit. But the other question is, if I do a drawing here, I think this is really, really close to that 1/2 inch or whatever. I think this is 1/2 inch here. But the tolerance is that this guy has to be smaller, and this other guy has to be smaller as well. So maybe what I'll do is I'll bump the tolerance here, where the 0.25 is max and the tolerance is lower, so this tolerance is closer, this tolerance is closer, and I might actually move it a little bit so they're closer. Because basically this guy should be like, maybe like 10 thou into itself, but there's a 10 thou stack up. There's a 10 thou because this guy could hit 10 thou to 20 plus or minus 10 thou. So let's say the blades are 10 thou, but they could be up to 20 thou smaller. So this thing only almost has to be 30 thou smaller. If that was the case, then this is minus 0.15. 0.015. So now it's a little bit tighter. And then this guy is going to be the same deal here. Alright, so a little bit closer now. So we'll see. Probably tomorrow morning is going to be when I check everything and make everything look good. I'll spend an hour and a half looking at that, making sure everything is kosher there. So this guy and this guy, making sure that that's good. And then another thing that we need to do is we need to re-update this assembly. So I might film some videos tomorrow morning and might as well just do it all in a video as long as I get everything done. But the idea with this coming back to this series is that this is now going to go into production. So what I want to do is I want to do the 2 new expansion modules. Well, basically 3, which are the stand, which uses these 1, 2 here, and 1, 2 here, and go down, and then with that you put a bucket underneath it, and the bucket collects all the flakes, all the shavings of all the parts that fall down into the bucket. And then these 2 here, these 2 here, and these 2 here, these 2 here and these 2 here go to a funnel that goes on the top. So a hopper, a sheet metal hopper that goes up here and up here like that, and up here like that. And then it's also for a motor attachment. So you could have a motor that goes here, that goes on this bottom portion, that basically attaches probably to this side. I was thinking about originally sticking out here, but you don't have a lot of clearance there. So I'll probably have it stick from this side, and then the motor will basically mate up with this side piece here, and made up with the side of this bearing. So if we look here straight on, well, it's not straight on photo, but pretty close. So it goes here, and then it mates up with this bearing over here on this side. And then probably have some sort of adjustment here so you get the meshing right here. So any sort of tolerance stack up, you could compensate for that by just pushing the motor over there and then tightening the bolts on it. And then so this guy will turn this way, which will make this guy turn this way. So this motor will have to turn. Here it is clockwise, but on if you're looking down the shaft. So if you're down the shaft, it's clockwise. Counterclockwise. It's going to spin counterclockwise. This guy spins up, this guy spins down. So it's got to spin this way. So this motor here will turn counterclockwise. If it's out here, this motor will turn also counterclockwise. So no matter where you put it, it's going to spin counterclockwise. So really they have a choice whether they want to put it over here or over here. And then obviously putting it down here is hard. Putting it up here is hard because the hopper is there. So pretty much either here are the 2 only places that you have to put it. You can put it underneath, but obviously it's going to get in the way of the pellets coming out. So that, and then maybe have a downwards funnel also to go to the stand. So again, the stand is basically going to be here, and this is going to be similar to my first multi-shooter project where it's just like the parts slip together or whatever. So it's going to go, it's going to have like a funnel that goes maybe inwards, maybe just like a printed funnel that just directs, because again there's no stress there. Up here there is stress, so this is going to be a welded steel funnel. Then down here maybe a 3D printed funnel or something. and the pellets are falling down, and it's directing it so that the pellets don't fall outside the bucket. Or what I'll do is you could line the stand with sheet metal so you could see, and that'll keep you from sticking your hand accidentally down here and it pinching your hand. So I'll probably do sheet metal that is basically on the side of the stand. And then that will basically make sure that those pellets fall down directly into whatever bucket you stick underneath there. And that's just going to be regular steel tubing there, and then like a steel cross brace to keep the steel from opening up. So make like a little T-bracket. So a little T-bracket that goes off of it. Put everything together and then weld it all up. So basically it's going to go down like this. So leg that goes down, cross brace, cross brace, cross brace, cross brace. And so now everything's nice and sturdy. So because this is really heavy, so you could put a lot of material up here, or even like you could put a bucket. You could do a modification, put a big bucket up here, and this is not going to buckle down here because it's got braces everywhere. And then the sheet metal goes up to that point, and so also the sheet metal holds everything stiff as well. And then you slide your bucket underneath, and all the pellets fall down into the bucket. And so that's for the bottom. And for the top, the hopper, it's just going to have a sheet metal that goes up this way. Same deal, this way. And then do some sort of controls or something for the shredder. Maybe some load. I might do an Arduino setup where there's some load sensor. And when it sees that the load gets high, it reverses, backs it up, and maybe knocks the piece of plastic around. So maybe does like 4 or 5 of those backups. Because when you do a back drive, eventually this blade comes up and knocks the material around. It'll knock it around, and eventually it'll land in a different spot. And then it'll try it again, and then try it again, knock it out. Okay, get stuck, knock it out. But we're gonna see what big motor we can place on here. So the idea is, in the meantime, we're going to finish up this project. This is going to take precedent over the DIY metal mill, so we want to get this done. And when I run out of inspiration, we'll do the DIY metal mill video. But in the meantime, we're going to have 1 week to get the prototype. So obviously this design right here needs to be finalized by tomorrow morning. So tomorrow morning, by the time I give them a go-ahead and I send them all the files that are the finalized files, and I'm going to tell them that indeed these are different, these are the files that you're going to use, and these are the tolerances that you are going to hit, and these are all the drawings, blah, 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 whatever. Once I do that, then that's pretty much set. All these whole locations and the whole thing is set. And then we have 1 week. We get the material, we get the prototype in, and then after that we have a order of 8 come in within another week after that. And by then we need to have the design for the hopper, the motor, and the stand finalized. So we're talking 1-2 weeks. We're talking about 3 weeks. 3 to 4 weeks we want to have the design finalized and be working on design, because these are going to start being shipped, and some people might want the stand and motor options for this guy, and it's going to hit the store, and it's going to hit the stores, online stores, so they're going to be available, and people are going to be asking about the motor, and so I want that to be available. So I want to be able to give them a lead time on that, and also a place that they can go check for updates. And because again, in about 2 months, this is going to be what I'm going to be relying on for my income instead of my day job, is these projects. And mainly this project is the only project that's going to be out until I finalize and start producing all the rest of them as I get my machines going, because now I don't have access to machines like that. Alright, so that is basically it. So we will start to... I'll be back tomorrow morning to start finalizing this guy, and I'll bring you guys with me on the video, and that one will be as long as it needs to be. I might break it into a couple videos, and that will be all caught up in that case. tomorrow morning with because of the 2 videos I missed last week during the day. So this is Shredder Part 12. Stay tuned for tomorrow morning for Part 13 and forward to make the stand and also the hopper for this model, and also to update this this assembly. Alright, so this has been Steven from Legit Tech Tutorials and the green... Oh, we're actually 5 minutes. We still have 5 more minutes. Okay, so what are we going to do now with 5 minutes? Okay, so basically I think I'm going to look at this with a fresh mind tomorrow, about 8 o'clock in the morning, 8:30 in the morning. And then we'll have an hour. Well, yeah, we'll have basically an hour to get it done. Because right now I don't want to make any decisions as far as the tolerancing, because you know it's 12:30 in the morning. So yeah, hopefully you guys understood that on what we're making here as far as the stand off these 4 holes in the bottom and the hopper off these 2 holes, as well as the motor mount off these 2 holes. Hopefully you understood how that works and how that's going to work. And hopefully you guys will come along with me on this journey to do that. And we'll also update this model here, and hope that you would see one of my projects here. I have a couple that have been done in real life, but this one is one that will be done in real life and also sold around the world, and well, mainly around the United States, but also around the world. So I think it's going to be pretty interesting, and so I definitely wanted to revisit this as now it's becoming a pressing issue. So I'm going to put in quite a bit of looking into this tomorrow morning as I get my final quote sent to me, and most of this shouldn't change, but I do have to bump up the count of these bearings here. So the count of these bearings on the inside, to get that right, I need a total of 4 per machine instead of 2. 8 per machine instead of 4. So I need another set of 4 on this machine, which will probably not change the price at all. So, and then we also need to figure out the shipping, how we're going to do the shipping situation for this guy, because each machine is pretty heavy. And you can see here from the top. If we go stop there, the properties, and this of course is assuming that we don't have any sort of bearings in there. They're about 24 pounds. I'm saying this one's probably 30 pounds. They're extremely, extremely heavy units and very, very bulky, robust machines. Very sturdy. Okay, so basically that's all I really wanted to talk about in this video. I just want to mention that we are getting back into this one, and this is going to be very interesting because we'll actually see this guy go on the market very soon. And this is going to be a priority for the videos in the coming future, as most of the stuff that you're going to see there is not going to be need to be like that precisely machined. All these extensions, all these extension modules, except for this, obviously this needs to be very precise, and one of the reasons why I'm building the water jet, and that's probably going to be the first thing finished. So yeah, there's that. Okay, so this has been again, this has been Steven from Legit Tech Tutorials and the Green Engineers. I thank you guys for watching this video, the Shredder Part 12, and I will see you guys tomorrow morning for maybe Part 13 and 14 or something. We'll see. Alright, so I'll catch you guys in the next video. Take it easy. Peace.